Right, in this series we're going to start the new series on trigonometry, and first we're going to look at Pythagoras' theorem. And Pythagoras' theorem is very closely related to trigonometry really, because it's about triangles, which is basically what trigonometry is about. And because in trigonometry you need to find angles and solve triangles, but Pythagoras is good for finding lengths as well. And when you try and solve a triangle you find all the angles and lengths, so it's pretty good to understand it. So this is basically what the theorem says. It says that c squared is equal to a squared plus b squared. Meaning that if we draw a square here, on this side here, this side that's opposite the right angle here is called the hypotenuse, and that's the longest side on the triangle. So if we put a square on here, the sum of these two squares is equal to this square here. The area of this square plus the area of that square equals the area of this square on the hypotenuse. So then what we can do is we can square root, and we can find this length here, c. So let's do a few examples on that. Here's my first example here. So I'm going to square them. 25 and 81. And then I basically just add these up. And I get 106 as my length. But we want a square root that, so it's going to be a square root of 106. Which you could do on the calculator. But I'm not going to do the calculator. All you need to do is find your square root button, which generally looks like this sign here. This sign on most calculators. But check with your manual for that if the question wants it in a decimal form, because all calculators work slightly different. So the first one was the square root of 106. I'll just write that here. Okay, the next example. And I'm gonna add them up. 346. But remember, with square root, so again you can work that out on your calculator to however many decimal places or significant figures the problem asks for. Or you can write it in third form, which you should know how to do that from your algebra class. I've got some videos on that if you need to check up on that method. This one's big numbers, but don't worry about it, it's still not too hard to work with. We should know how to square these. Because remember, you get these extra zeros when you multiply, so. And then, of course, when you add them up, you get 250,000 square root of that. before we go on, I just want to tell you to be careful about the measurements on the problem, because you see here it says centimetres and on this one it's metres. And if you put the answer in the wrong units on an exam, you could lose marks. So just be careful you write down the answer in the same units you've been working with throughout the problem. So now that we've done these examples, I want to just show you two quick special cases, and I'll explain why they're special in a minute. First, let's just do them. We've got 3 squared and 4 squared, that's 9. 16, now that's up to 25. And the square root of 25 can be worked out easily, that's 5. So that was a pretty good example because it works out quite nicely. The arithmetic's easy. And there's a square root that you should know. Next one is another special case. And then when I add these up, we'll get 169. And if you memorise a lot of your square roots, you should know that the square root of 169 is 13. But if not, use your calculator if you're allowed to use one. Now, the reason that these are special cases is because in these ones, the length of the hypotenuse is a whole number. You see in these are all whole numbers. And in these ones, these are all whole numbers. This is also a special case because if you notice, these two are multiples of them. So you can find this square root out here on your calculator if you like, and you can confirm that this is also a triplet. These are called triplets. These are called Pythagorean triplets because they're all whole numbers and they work out nicely. So try that one, see what it comes out to be. I'll put the answer on the video in a note for you in case you need some help.